from before break and there's a gizmo before break. The warm-up questions are really good to study, and notes. And so what I have done is in your classwork, I have included the conduction Google Slides, part 1 and part 2, so that's what we went over before break and what we're going over today, and it has links to the videos that we watched and all that sort of stuff, so you can refresh your memory. And then I also included a list of things to review, so the gizmo and the reading and the notes. And then if you go back one more week before break, there are the objectives, the reading, and the notes right there in the classroom for you to review. Okay? And I have returned all of the gizmos and all of the classwork, all of the readings from before break, so you can look at them, edit them, do whatever you want to them. All right, so that's part 1, is the quiz and all those things to do with the quiz. Then do Wednesday night is convection reading, but we're going to start it in class today, okay? So most people, I would say in each of the classes so far today, about half the people actually finished the reading. It's only 2 pages of reading and then 6 questions. Okay, so it's not that hard, it's not that big of a load, but it is going to start us talking about the next topic. Finally, if you got an 80 or below on your quest, your quiz test that we had before break, you can do a makeup. The makeup help is this Tuesday from 4 to 5, and then the makeup quest is going to be this Thursday afternoon. So if you want to do the makeup, then come to the makeup extra help. If you want to do the makeup but you can't come Tuesday from 4 to 5, email me, we can try to find a time. And then the makeup itself is going to be Thursday, and it's going to be one of those things where I give you a link at noon and you have until 7 p.m. to finish it. So you can kind of pick wherever in there works best for you. If you got below, if you want to redo just the multiple choice or just the open response, you can, okay? So I'm letting you make them up separately. So let's say you did fine on the open response, but you didn't do as well as you liked on the multiple choice, you can just retake the multiple choice. And again, I have returned all of those, so if you go into Google Classrooms where you took the test, you should be able to see what you got, and if you click on the icon, you should be able to see what you got right and what you got wrong. If you need help finding that, let me know after class and I can help you look at it. Okay, so those are the things that are going on, the big things that are going on this week. For today, we're going to look at the Unit 2 test results and the results of the survey that I had you guys do. Then we're going to look at the conduction slides. We're going to do a class demo, and then we're going to start the reading for conduction. Any questions about what's going on this week or what's going on today? Cool, okay. So, Unit 2 quest results. So, the average was a 90. The median was a 95. So that means while the average was a 90, it was grouped higher than 90. So like there was more people that took, so more people that got an A and then there were some outliers at the bottom. So overall, you guys did great. There were only a handful of people that got below an 80, and so if you got below an 80, then definitely come see me and we can do the retake and you can boost that score up, but most of you guys did really well. And then I had you guys do a exit survey that just kind of told me what you liked about Unit 2 in terms of activities and what you wanted to see different. So what I took away from that is that, first of all, some quick and easy things that I'm going to try to work on right away is I'm going to find alternative times for extra help. good number of people said they wanted to come to Extra Help but weren't free that one time. So I'll survey you guys and see what other times you want in the near future. And you also really liked reviewing the homework, which is really good to know because I haven't made a whole lot of time to review the homework, but it seems like enough of you find that really helpful. So I'll put more time into the schedule to do that. The things that's going to take a little bit longer is to investigate how to make Room and Zoom together go better. I know that people really like when they're separate, but we do have to be together sometimes for different reasons. And so I will definitely try to make that as smooth as possible, and I will do some investigation. Can't do it overnight, but it's on my to-do list. Also, more creative, interactive activities and projects. I heard that loud and clear. So we're going to do a few small little creative projects coming up and some interactive activities. And we will make as many of the activities hands-on as we can during this pandemic. And then I also heard that you guys like the Nearpods as opposed to just the straight notes and PowerPoints, and more interactivity, so I will try to do some more Nearpods. Was there anything else that you guys feel like I missed, or you feel like that pretty much gets the scope of what you guys are feeling like for class? Okay, awesome. All right, so the warm-up. This is super important. Heat flows from what to what? Danny, kick us off.
Hot to cold.
Hot to cold. Excellent. Good. And so within that is implied, but not necessarily directly saying, that cold doesn't go anywhere. Cold doesn't travel, only heat travels. Do you want to add something, or?
No.
Okay. What are the three kinds of heat transfer, Abby?
Convection, conduction, and radiation.
Yes, convection. When things come together and actually touch and are touching. Conduction, convection, when fluid moves, and radiation, when things move through space. Excellent. Conduction is when heat transfers by what? Danny?
Touch.
Touch. Excellent. Yes. That's why we put our hands like this, because it's the touch. Direct contact. Let's see. Someone online, someone on Zoom. What is an example of conduction? Tessa, what is an example of conduction?
If like spoons in like a mug of a hot liquid.
Perfect.
Yeah.
Excellent. Good. A spoon in hot cocoa heating up, right? Because the spoon is directly touching the hot cocoa. If the spoon was hovering above the hot cocoa, that would be a different kind of heat transfer. How does conduction work at the atomic kinetic energy level? Yeah.
The molecules start moving around and it kind of like leads one to another, like a dominoes effect.
Excellent. All right, so kind of like dominoes. I like how you said that. So basically, one particle is moving fast, so it has a lot of heat, and the other particle is moving slow, and so it has less heat. Okay? So the more kinetic energy, the more movement, the more heat, touches the bumps into and transfers energy to, the less kinetic energy and less heat. And this faster one slows down because it gave its heat energy to the other one, and the slower one speeds up. And then what is, Charlotte, what is thermal equilibrium?
I wasn't sure. I didn't get this one.
Okay, so what does thermal mean?
Like hot.
Heat.
Hot.
Mhm.
Heat, yes.
Specifically heat. What do you think of when you hear the word equilibrium?
Equal.
Yeah, so equal heat. That's exactly what it means, okay? So equal temperature. So they're moving at the same exact speed. Good. Okay, so both substances are the same temperature. The molecules move at the same average speed. All right, so I'm going to show you, there's a video that does a really good job of kind of like showing a metaphor for conduction and why some things are good conductors and why some things are bad conductors. So things that conduct well are called conductors, that transfer heat, conduct energy well, and things that do not conduct are called insulators. So insulators stop the transfer of heat, and conductors enable the transfer of heat.
So I have 2 squares of material, a couple of rubber rings to stop things falling off the edge, and then I've got a couple of ice cubes. So let's see what happens. So this guy is still pretty okay, whereas this one's just a load of mush. Now, both of these things, they look pretty identical, but actually they're made out of different materials. This one is made out of plastic, and this is made out of metal. But the important thing is that both of these started, and they are at the same temperature. However, actually, when I'm holding it like this one here, even though it's the same temperature as this block here, feels a lot colder. And this is because of conduction and how some materials are better thermal conductors than others. Now, these blocks just represent the particles in a typical...
Okay, so I want to just stop there for a second. So basically what he's saying by conductors and insulators is this first one where there's the ice cube that isn't melted is on top of plastic. Plastic is an insulator. And so by an insulator, we mean does not allow the transfer of heat. So it does not allow the outside air and the bottom underneath the plastic heat to transfer into the ice. It stops it from transferring, it insulates it. Whereas the second one, where it's mush, is made of metal. Metal is a great conductor, so it facilitates the transfer of heat from the the environment around it into the ice cube, and so it melts, all right? So now what he's going to talk about is why things are conductors versus why they are insulators.
Because this block here feels a lot colder. And this is because of conduction and how some materials are better thermal conductors than others.
And so when he said it feels cold, so good conductors feel cold because they are conducting the heat out of your hand into whatever it is, okay? So this table is a conductor. So the metal on your desk, the metal legs, if you touch the metal legs, they feel cold, right? So they feel cold because metal is a good conductor and it is actually conducting the heat from your hand to the leg. Now, let's say you touch the clothing on your shirt, your cloth. It doesn't feel cold, right? That's because the clothing we're wearing is a good insulator. So it insulates. So it doesn't allow the heat to transfer from your hand to your clothing because it insulates the heat into your hand.
Now these blocks just